Hi everyone, I hope you're clear with the concept of the components of force. So we'll start with the problem for the components of force, but before we start with the problem, I just want to give some insight, or we'll just try to highlight some of the topics which have been covered in the previous video lecture. So if suppose you have a force, just only one force is acting which is inclined to some angle, then we'll just look of how it is being solved with. So let me just take, I have two axes, F, Y, and then another axis, F, X, and then a force is acting with an angle of theta with respect to the horizontal. Please note this point. Theta is the angle between the force F with the horizontal axis X. So basically what we have seen is Fx is equal to F cos and Fy is equal to F sine theta. If suppose the same kind of problem is existing such that you're going to have one axis Fy and then another one Fx, and the same thing, let me just consider force F1 is acting, but here if the angle is given as alpha, alpha is the angle between the force F1 vector and the y-axis. Please do change or convert such that you're taking this angle into constraint. So again let it be theta 1, so which means theta 1 is equal to 90 minus alpha. Here again it will be the same concept. Fx is equal to F1 cos theta 1 and Fy is equal to F1 sine theta 1. So whenever you're dealing a problem, always ensure that between the force vector and the x-axis, the angle should be between the force vector and the x-axis. So with no other further delay, we'll just get back into the problem. So this is one problem which is given to it. I'll just a force is given such that you're having a 300 pound, and then alpha is the angle that is made, and then you have another force which is acting along a dash. The direction may be like this or maybe like this, we'll decide. And there's another force which is acting along b dash. Here again you have two options, the direction can be along the b or along b dash. So this is the problem that is given to us, and then they have been asked, or we have been asked, to find out what is the other two components which is acting along a dash and then b dash. And most importantly, we are also supposed to find what is the angle alpha when one of the forces is given to us. Okay, so with no further delay, we'll just scratch back ahead upon the parallelograms law. So your parallelogram law, according to what we saw, is you'll be having one vector which is acting in the positive direction, and that will be p vector, and then you have another vector that is acting in the another inclined fraction, which is going to be a q vector, and then you have a resultant vector which is actually the diagonal that is formed because of the extension of these p vector and q vector. So basically then that will give you as r square is equal to p square plus q square plus 2pq cos theta, where theta is the angle between p and q, and then you have another angle alpha which is between the resultant and the horizontal p. So that goes like tan alpha is equal to q sine theta divided by p plus q cos theta. Okay, so both these thing is valid when you have p vector that is acting in the positive x, or let me just put it in a simpler term as on the positive value, and your q also will be in the positive direction only. But here this 300 pound that is given to us is actually not acting in the positive direction. It is acting in this particular fashion. Okay, if you have a resultant that is acting in this particular direction, then this particular formula will not be carried as a whole. So which means we have to do just a small modifications, and then that will help us to get back into the problem. Okay, so what is that we are going to do is very simple. We'll just take a classical example wherein let me take a force that is acting over here, P, and then I have another force which is acting in this particular direction, Q. So now if we try to find out or try to construct a parallelogram such that your vertically inclined line is parallel with the Q, and then you have another parallel line which is horizontal, another horizontal parallel line with a vector. So now if we construct a resultant vector, it will be in this particular fashion. Sorry for the inclined line. So this will be in this particular fashion. So your theta is the angle between your P vector and Q vector, and then another angle is getting formed, alpha, which is between the P and the resultant vector. Okay, now if we try to modify the previous formula which we derived from the parallelogram, you will be able to find that your resultant is equal to P square plus Q square minus 2PQ cos theta, and similarly your tan alpha is equal to Q sin theta divided by P minus Q cos theta. So which means this is the methodology that we'll be using over here. You have a resultant acting in this particular direction, so obviously you're going to have one vector which is acting or which was supposed to act in this particular direction. Let me just take it as Q, and then I have another vector which is going to be acting in this particular direction as P. So once a parallelogram is being constructed, then I'm sorry for it, let me just change it. So this is where your resultant will be acting, and this 300 pound is actually the resultant. Okay, so we are supposed to find out the unknown parameter. Here you will be able to find, in the previous case, the value of one of the component is given as 240, and it has also been stated 240 is actually acting in this particular direction, which is A dash. So basically they're given us what is the value of P, which is 240, and then you're supposed to find out what is the value of Q, and then you're supposed to find what is the value of alpha, right? So here again there are two ways of doing this particular problem. One, we can solve by using the Parallelograms law, and then you can also solve the same problem using the triangles law. Okay, so I hope you have got the problem to some extent, got an idea of what is that we are trying to do. So here they have given us what is the force that is acting along the direction A dash, which is 240. So which means you have a force over here which is 240 pound, and then you're supposed to find another force Q, and then the corresponding value of alpha, right? So the problem that is given to us is pretty clear to us. Now we'll try to solve this particular problem. So as we have seen earlier, we are pretty sure of what the formula is. So here a small modification is do required. So it is r square is equal to p square plus q square minus 2pq cos theta. Similarly, you have tan alpha, which is equal to q sin theta divided by p minus q cos theta, right? So over here the value of r is given to us without any issues, that is 300 pounds, and then the value acting along A dash is also given, so we'll just take it as P, and the one that is acting along B dash is Q. So P is also given to us, so that value is 240 pounds. So when we are substituting the value, it is 300 square is equal to 240 square plus Q square minus 2 into 300 into 240 into cos, and this is where again we have to do a small bit of trigonometrical calculation. So this is actually a straight line, so which means this angle that has been formed is 180 and this angle is known to us, which is 60. So obviously the angle between your P and Q, which is this particular angle, is going to be 120 degree. So we'll just substitute that as 120 degrees. So the only unknown parameter that we have to find is Q. So if you do the normal arithmetic calculation, you're going to get a value of 336.34 pounds. Right? It's as simple as that. But the only care that should be taken is this particular minus sign that comes into picture. Okay, because when we are using the general parallelograms law, we'll be able to find that it is a positive sign, since because there is a change from this direction to this particular negative direction, you are going to get a minus value, right? So then without any further delay, we'll also calculate the angle. So it is tan alpha is equal to Q sine theta divided by P minus Q cos theta. All the values are known to us. The value of Q is found, so it is 336.34 sine and the angle theta, which is 120, divided by the value of P is 240 minus 336.34 cos 120 degree, and again if you're going to substitute it, you're going to find, or you will be able to get the value alpha is equal to 76.15 degree, right? So the only things that you have to be very careful over here is this particular negative sign and then the theta that you're going to use. Here the theta is not given to us directly, it is given as 60 degree, but the value is 180 degree for the whole line, so which means the angle between the P and Q is going to be 120 degree. So these are the only steps that you have to follow over here. I hope this set is much clear for you. So this is the formula, substitute it and then you get the value of your Q. So here again, one thing which I didn't mention in the previous slide, which I forgot to mention in the previous slide, is here you're going to get a quadratic equation because the value of Q is not known to us. So here you have to go for a quadratic equation. You're going to get a positive sign and a negative sign. So which will be the correct one? Already we have discussed that here you're going to have P and here should be the direction of the Q vector, or this will be the direction of the Q vector. So which means Q obviously is positive. There's no way you're going to get a negative value. So this value will not be existing. So only the positive value is going to exist. And similarly, tan alpha you can find out and then you have these subsequent values. Okay, so this particular slide is actually typed out so that you get a better understanding of how the problem is being approached with, right? So with this your problem is over. Okay, so this particular problem now has been solved only by using your parallelograms law. Fine. The next part is where we take the same problem and then we try to solve it by using the sine law. Okay, so there's a small difference between the figure that is used in the the sine law and the figure that is used in your parallelograms law. When you're using a parallelograms law, you'll be able to find that the tail of all the vectors, which means your resultant vector and then the other two force vectors, will be meeting at a particular point. Whereas when you're going to use the sine law, it's a little bit different. Okay, so when you talk about your sine law, you'll be able to find, or that particular important point is, your force, or the first force, let me just take it as F1. So your first force is not going to change its direction. It is just going to remain the same. So for us, P vector. Okay. But the major thing is the next vector or the second vector, which is Q vector over here. Let me just change it to P. So the Q vector will be placed such that its tail is actually kept on the head of the first vector. I'll repeat, P vector is going to remain unaltered, whereas Q vector is placed such that its tail is on the head of the first vector. So this becomes the Q vector. Now your resultant vector is very simple. It should have its tail with the tail of the first vector and its head on the head of the second vector. So this is how a triangle should be considered when you are going to use it for your sine law. Okay, I'll repeat it. Your P vector is complete, whereas your Q vector should be placed such that its tail with the tail of P vector. And the third and most important point, your resultant, such that its tail is kept on the tail of P vector and its head is kept on the head of the Q vector. So this particular problem is a kind of research or a reverse kind of process wherein the resultant is known to us, it is directly known to us, obviously is going to be a P vector. So the next comes the closing vector, which is the Q vector. So this is where the Q vector we have considered that it will be acting in this particular direction. So I'm just going to change from this particular point to this particular point. So as told, its tail should be with the tail of the P vector. Okay, I'm sorry, tail with the head. Please make a note. The second vector should have its tail with the head of the first vector. So the tail is over here, it's on the head, and then its head will be meeting with the resultant, and this becomes the Q vector, right? So this particular angle alpha, that is the one that we are going to find out, and then you have 60. So if this angle is 60, obviously this angle is also going to be 60. So then this particular angle should be found out. So this particular angle is not that difficult, it's almost very simple. So it is 180 minus 60 minus alpha. Okay, or let me just rewrite it. This angle, let me just take it as beta. A trigonometry, the sum of all the angles in a triangle is equal to 180 degree. So which means it is 60 degree plus alpha plus beta should give me a value of 180 degree. So which means beta is equal to 180 minus 60 minus alpha. So which means beta is 180 minus alpha. So I'll be just writing it over here as 120 minus alpha. Okay, let me just resketch the entire scenario. Okay, so this is my P vector, and then this becomes my Q vector. This is the resultant vector. This angle is 60 degree. This angle is 120 minus alpha. Okay, so P, Q and R. Okay, now the sine law is very simple. Q divided by sine of alpha is equal to then P divided by this particular angle divided by P sine of 120 minus, that is equal to R divided by this particular angle. So R divided by sine 60, right? So the values that are known to us is very simple. So it is Q by sine alpha, that is equal to P, P is given to us. So it is 240 divided by sine 120 minus alpha divided by r, which is 300 divided by sine 60. So here we are supposed to find what is the value of q and what is the value of r. So it's very simple. So just consider these two terms, find out what is the value of alpha, then the first term and the third term, and then you can find out what is the value of q. Okay. So the next slide will be much detailed. So we are going to have, again, let me just redraw it. P Q 60 120 minus alpha, right? So when we consider just the first two terms, only the unknown value is alpha, substitute it, you are going to get the alpha value as 75.15. Again, consider the first term and the last term. Again, the unknown parameter is q, obviously. I'll be just changing it, q. So here again, just a normal substitution which will tell you what is the value of q, right? So now with this particular part, you will be able to find when you used your parallelograms law, this is the value of q that you got, and similarly your alpha again was 75.15 degree. Again, if you're going to use a Sine's triangle, Sine's law, again you're going to get the same set of values. So basically, which means there's not much of difference in which method you're going to solve a problem with. The only thing that you have to be very careful is take the angles properly, try to correct or recollect your basic ideas with regards to your trigonometrical calculations and a little bit of arithmetics. So once you're clear with that, either you can go for your parallelograms law or your sine law, wherein both the things will yield you the same results. Okay, so I hope this video could have been useful to you. If there's any doubt regarding this particular video, or if there's any step where you find it a little bit difficult, please put it in the comments. Maybe at the later stage I'll be able to tell you in a